Welcome learners to KCSE revision. I would like us to look at this question which was tested in year 2008 and it was carrying 10 marks. This is a Form 2 concept which was tested in that year. It is under measurements or volume of solids. Welcome. So here we have a cone. And in the cone, we have some water up to this level, that the depth of the water in the cone is 30. And the radius of the water surface here, Lana, is 21. So in this case, you are told to take pi as 22/7 as you work out the problems. We look at question A. Calculate the volume of the water in the vessel in centimeters cubed. Calculate the volume of the water in the vessel in centimeters cubed. Learn, this water here inside this conical vessel is taking the shape of a small cone here. It is taking the shape of a small cone, and therefore it is a matter of finding the volume of the cone. And therefore the volume of the water in the cone, it is equals to 1/3 pi r squared height. It is equals to the volume of a cone, Lana. This is the formula, and therefore you just come and say this is 1/3 times 22/7 times r. Your r, Lana, is 21, so r squared is 21 squared times the height of our cone, which is 30. You work out that, Lana, using a calculator, and you should get 13,860 centimeters cubed. This is the volume of the water in the cone. It is taking the shape of the cone. That is why we have used that formula. We go to part B, Lana. What are we told? We are told that when a metasphere is completely submerged, when a metasphere is completely submerged in the water, if it is dropped in the water, the level of the water in the vessel rises by 6 centimeters. Then we are told calculate the radius of the new water surface in the vessel. Lana, we are told that a sphere is completely submerged in the water. So let us assume that our sphere is this one, Lana. That is our sphere. And we are told that once it is submerged, the level of the water rises by 6. It rises up by 6. And therefore, maybe we can draw here, have something like that. So it rises by 6. This height here, Lana, is 6. The level of the water rises by 6. So suppose we do some shading of that kind. So like that. It rises by 6 centimeters. Remember the depth of the water was 30 centimeters from here to here. And so, Lana, you are now told to calculate the volume of the radius of the new water surface in the vessel, which is the radius of the new water surface. Our new water surface is this. You fix your r there. You fix this r. You can call it capital R there. So what is that r? How do you get it, Lana? You use what we call linear scale factor. Linear scale factor. In other words, you use the ratio. Linear scale factor is the ratio of the corresponding sides. Ratio of the corresponding sides. So you come and talk of what? Small height. Look at this, Lana. Small height over capital height of the water. Small height over capital height. So you talk of small height, which is 30. Small height, which is 30 over, look at this capital height from here to here is what? From here to here is 36. 30 plus 6 is 36. So small height Lana divided by capital height, which is 36, is equals to what? We go back to our diagram, Lana, is equals to small radius. Look at this, small radius over capital radius. Small radius, which is 21, over capital R. So we come and write 21 over capital R. There we are. So you can simplify here by 6, 5, by 6, 6. So we are talking about 5 over 6 is equals to 21 over capital R, Lana. Then cross multiply, you would get 5R is equals to 126. Divide by 5, divide by 5. Lana, our R is what? Our R should be 25.2 centimeters. That is the radius of the new water. We go to part 2 of the question, Lana. Calculate the volume of the metasphere in centimeters cubed. What is the volume of this metasphere in the air in centimeters cubed? The volume of this sphere, Lana, the volume of the sphere is equal to the volume of the water displaced. It is equal to this volume of the water displaced. It is more physics. And therefore you write it is equal to the volume of the water displaced. It is equal to the volume of the water displaced, which is equal to what? This water here, Lana, takes the shape of a frustrum. This is a frustrum, Lana. Look at it. This is a frustrum. And therefore it is equal to volume of a frustrum. The volume of the sphere is equal to the volume of the water displaced, which is equal to the volume of a frustrum. Therefore, Lana, how do you find the volume of a frustrum, which would give us the volume of the sphere? So the volume of the frustrum, Lana, is got by what? It is got by getting the volume of the original cone. Look at this. It is got by getting the volume of the original cone. Then you subtract the volume of this small cone. Maybe I can write that volume of the original cone minus the volume of the small cone. Which is given by what, Lana? Volume of a cone is generally given by a third pi r squared h. A third pi r squared h. We can use capital letters for the big cone minus a third pi r squared height for the small cone. Here we use the small letters. Then we check. We move on. We say this is equals to a third times 22 over 7 times the big radius. Look at our big radius, Lana. The radius of the big cone is 25.2 squared times the height. The height of our cone, Lana, was what? 36. 30 plus 6, 36. Minus a third times 22 over 7 times the radius of the small cone, Lana, is what? 21. So 21 squared times the height of the small cone, which is 30. You work out that with the calculator, Lana, and you will get what? This one will get 23,950.08. Okay, minus for the small cone it is 13,860. We had got it there in the very first step. You subtract and you get what? You get 10,090.08 centimeters cubed. This, Lana, is the volume of the frustrum, which is the same as the volume of the sphere. In this case, there we are. We go to part 3 of our question, Lana. part 3 of our question. Part 3 of our question is here. We are told to calculate the radius of the sphere. What is the radius of the sphere? Learner, we know that the volume of our sphere from this previous step that we've just done is what? It is 10,090.08 centimeters cubed. But we know that the volume of a sphere, learner, volume of a sphere is given by what formula? 4/3 pi r cubed. You should have that in mind. 4/3 pi r cubed. And therefore, learner, you just need to equate this formula to that for you to get your radius. So we talk of 4/3 times 22/7 times r cubed is therefore equal to the volume, which is 10,090.08. Good. So you work out this, learner. This is 88 over what? Over 21 r cubed, which is equals to 10,090.08. You multiply both sides by the reciprocal. Look at that. You multiply both sides with the reciprocal. There we are. So this cancels out, and therefore you are left with r cubed is equals to what? R cubed is 2,407.86. Working out that using a calculator. And so, learner, finally, to get our radius, you just need to find the cube root. Because this is r cubed, to get r, you find cube root. And therefore, r is equals to cube root of 2,407.86, which gives you what? Which gives you 13.4 to the nearest 1 centimeter, to the nearest 1 decimal place, 13.4 centimeter. So good. So we have come to the end of that question. Learner, go and practice with this question until you internalize.